Okay, so right away the difference is that yesterday we would have only had the x squared minus 16x and then completed the square and factored into a perfect squared binomial. We have this 55. If we took half of 16, which is 8, and squared it, is that what we have right here?
No.
No. So that's why we have to do some work to complete the square. So the first thing is we're going to move that 55 over to the other side so that we can get it into the form x squared plus bx equals some constant. In this case, we're subtracting the c over. Okay, so then that's what we have. We have our x squared minus 16x equals a negative 55. Now we're going to do our opposite of b over 2 for the 16, the negative 16. And I put a blank here because we're going to complete the square here, but because we have an equal sign, Michael, this is what you were talking about yesterday. Because we have an equal sign, we have to add that same amount to the other side so that it stays an equation. Okay, so we're going to complete the square for the left. Whatever we add to the left, we have to add to the right so that it remains an equation. They're still equal to each other because we can't add 5 to the left side of the equation and nothing to the right side and it still be equal to each other. So we will do our b over 2 for the left side. And that's a negative 16 over 2, which is a negative 8. And then again, we square that negative 8 to put it into that third spot. So we're also going to do the same thing to the right side of our equation. We're going to square a negative 8 and add that to the right side of the equation as well. Okay, so we simplify, and on the left we're going to get x squared minus 16x plus 64. Remember, that's what we said we needed up here. This 55 needed to be 64. And it's not just enough to add whatever so that it gets to be 64. Yeah, well, anyway, never mind. Because it won't work on whole equations. That's what we ended up doing is adding 9, correct? Anyway, so now we can factor the x squared minus 16x plus 64 into our x minus 8 quantity squared equals 9. And so that's the first step. We are going to then, we're not done yet because we have to solve for x. Here we've just gotten our equation into a perfect squared term equals a number. So now we're going to use our square root rules. We have something squared equal to 9. We want to undo the square so that we can get x by itself. So undoing the square means we have to square root both sides. So I've got this x minus 8 squared equals 9. To undo that square, I'm going to square root both sides. And that's going to give me x minus 8 on the left equals, and remember when we have an equation that we are square rooting within the equation to solve, then we take both the positive and negative root. Okay, so how now do I get x by itself on the left? Add 8. So I'm going to add 8. And here's how that's going to look on the right. We're going to take 8 plus or minus 3. Because we have positive or negative 3. So we have to add 8 to both of those to get 2 answers. So that's going to give us 8 plus 3 or 11. And 8 minus 3, which is 5. So our 2 answers are going to be 5 and 11. That's our solution set. Yes, because we're listing the 2 solutions to our problems, to this equation. Bless you. Yeah, I got it too, Michael.
Oh, let me have the answers.
Okay, so now we're going to complete the square. Since we added that 10x over, we're going to complete the square on the left, and remember, whatever we add to the left, we also have to add to the right. So b over 2 would be 10 over 2, which is 5. And we add the square of that to both sides. So we're going to add actually 25 to both sides. So we're going to get x squared plus 10x plus 25 equals a negative 4. And that x squared plus 10x plus 25 factors into x plus 5 squared, that quantity squared. Okay, so now to solve, we've got this x plus 5 squared equals negative 4. We have to undo the square, so we square root both sides. And that gives us x plus 5 equals the positive and negative square root of a negative 4. And remember, the square root of a negative 4 is the same as the square root of a negative 1 times the square root of 4. And what's the square root of a negative 1? I. So we have, and what's the square root of 4? 2. So we have I times 2. I'm going to write that as 2I. So we have x plus 5 equals positive or negative 2I. And then what do we do to get x by itself on the left? Subtract 5. And that's going to look like x equals a negative 5. Remember, we always put our real number first. And if we wanted to list this in set notation, because we have two solutions, we would write it as the smallest one would be negative 5 minus 2i, and then the next one would be negative 5 plus 2i. And there's the solution, imaginary solution to this quadratic equation. So here's another way to do this problem. This one lends itself to doing it this way as well. Not all of them will be as simple as this. So we talked about how this needed to be what, that 55 needs to be what in order for us to factor it into a perfect squared binomial. 64, because opposite, or b, negative 16 over 2 is negative 8, and then we square that to get 64. That's what we need this to be, correct? In order for us to factor it into the two parentheses. So what would I need to add to 55 to get 64? 9. So I could, if I add the same thing to both sides, then I'm still keeping my equation equal. And I get x squared minus 16x plus 64 equals 9, which is what we ended up getting after a couple of steps. Now the left again factors into x minus 8, right? Squared. And then we're now to where we were before, where we square root both sides. We get x minus 8 equals positive or negative 3. Then add 8 to both sides. So we get 8 plus or minus 3, which again gives us 11 and 5. Whoops, I want to put that as 5 first. Okay. So we got the same answer, a different process. And like I said, this one lends itself to just figuring out what that squared number needs to be and adding it to both sides, and it works out. They won't always be that way, and especially when we're working with fractions, that's a little more difficult to work with to figure out what we need to do. And so then the other method is probably the one you want to choose to do. Okay, so then the next problem we had, what was, everybody good with this? It was C. And that was x squared equals, was it a negative 10x minus 29? Okay, so what I would do then is, the first problem A, we had everything on one side equal to 0. So let's do that. That means I'm going to add 10x to both sides. And then I'm going to add the 29 to both sides. So I added the 10x and I added the 29, okay? So this is method 2. This is different how we did the first one. What does this number need to be in order for me to factor it? 25, right? Because 10 over 2 is 5. 10 over 2 is 5. And then I'll square the 5, and that's what should go right here. So that needs to be 25. How can I make that 25? What do I need to do to it? Subtract 4. So if I'm going to subtract 4 from the left, I have to subtract it from the right in order to keep it as an equation. So we get x squared plus 10x plus 25 equals a negative 4. And now we're in the same boat that we were in. The steps after this point are going to be the same as what you did in the last problem. So you can refer back to that. We'll get, we got x equals negative 5 plus or minus 2i. Okay, so solution will be the same from this point here as it was on the previous problem that we did. No change there. The change happens up in this area on how we're going to deal with it. Okay, so let me see if I can come up with one that is like this that you can try either way. I'll work it out both ways for you. Okay, so, and then we'll come back to B eventually. Everybody good? All right, so the second way I've got x squared minus 6x plus 11 equals 0. Half of my b term is a negative 3, and I know that I have to square that to get 9. So this needs to be 9 in order for me to have a perfect square. See how I've got 9 on the left there? So what do I have to do to 11 to get it to 9? Subtract 2. So whatever I subtract from one side of the equation, I've got to subtract from the other side. So that gives me x squared minus 6x plus 9 equals a negative 2, which is what I have over here, correct? So the work from this point down is the same on either one. Okay, so I'm just going to work on the right. So we know that this will factor into x minus 3 squared because we always use b over 2 in this spot. And then I have equals a negative 2. So to undo the square root,